Hello, algebra students. Here we are with our unit review video. All right, now the way this is going to work is I'm going to give you some problems. You get to practice them, and then you'll see my solutions, and I may give explanations on some of them. This is going to be a little bit longer than a traditional review video, but you have 2 nights to watch it. Excuse me. And you'll be the one responsible for making sure you study the parts of the video that you don't know. All right, so for example, if the first part is on integers, like it is, if you have trouble with this, you should be going back, watching a previous video, asking questions during class, talking to a friend, etc. Okay, so here's the first 6 problems. You go ahead and pause the video and see if you can do them correctly. My answers will appear. If you're still watching, here come my answers. This one is going to equal positive 2. This one will equal negative 2. The number 3 will be negative 24. Okay. Number 4 is negative 20. Number 5 is positive 12. And number 6 is negative 4. Okay. You can go back and rewatch the videos or come in tomorrow with questions for me. All right. Let's have you do problems 7 and 8. Go ahead and pause. If you're still watching, here come my solutions. This one will be negative 5, and this one will be positive 3. Remember that if you count the negatives, an even number of negatives results in a positive answer if you're talking about multiplication or division. Okay, an odd number of negatives, not whether the number is odd. This is an even number. 30 is an even number. There's only one negative. Listen as I read the problem. Negative 30 divided by 6. I said the word negative 1 time. I got a negative answer. That does not apply to addition and subtraction, only to multiplication and division. Here I see negative 45 divided by negative 15. I said the word negative twice, an even number of times, therefore my answer was positive. All right, let's move on to the order of operations. Notice I did not call it PEMDAS, order of operations. Okay, go ahead and pause the video. If you're still watching, you want to see my solutions. I know the order of operations has to do from left to right when you're talking about addition and subtraction. So I'll do 6 minus 10, which is negative 4, plus 4 is 0, and 0 is a number. It's not nothing, it is 0. It has a name. Number 10, the order of operations tells me to do division before I do multiplication. 20 divided by 4 is 5, and 5 times 5 is 25. All right, number 11. I ask myself, what does this exponent mean? Well, it means the thing in the quantity, namely negative 1, multiplied 6 times. Negative 1 times negative 1 times negative 1. Let's see if that all grouped together. It did. So now I can be lazy and clone it and put it right there. And so if I read this out, I would say the word negative 1, 2, 3, 4, 5, 6. This is going to be 1 times 1 times 1 times 1 times 1 times 1. And it'll be a positive 1 because there's an even number of negatives. All right, now on this one here, number 12, I have to pay attention to the order of operations. There is no quantity. The negative is not being raised to the power of 6. It's not. If there were parentheses in here like that, it'd be the same problem as 11, but there aren't. So I'm going to raise 1 to the 6th power, which is 1, and then the negative is out there in the front of the problem. Okay, I want to draw a little thing so we don't think those go together. All right. On this one here, well, I'm going to do inside the parentheses first. So we're going to negative 3 times 6 minus 8 is negative 2. Let's square it. I'll have a plus 10 on the end. And I'm going to go ahead and do this part. Now, if I've paid attention to problems 11 and 12, this one should be easy. I'll square 5, and then I'll make it negative. Okay, now the order of operations says to do the exponent still. Negative 2 to the 2nd power. That's negative 2 times negative 2, which is positive 4, plus 10. Okay, I've got to do my multiplication. Negative 3 times 4, negative 12, plus 10. I'll go left to right with subtraction, get negative 37 plus 10, and that'll equal negative 27. If you're wondering how I do that so fast, if you haven't figured it out yet, I do 37 minus 10, which I know we all know how to do, but with negative 37 plus 10, you see how the 37 is larger than the 10, and the 37 sign is positive, right? Well, my answer had a positive sign. Here on the second one, the 37 sign is negative. It's still bigger than the 10, the 37 by itself. The absolute value of 37 is bigger than the absolute value of 10. So I need a negative answer. It's the same problem. So in other words, if you can do 7 minus 4 and know it's 3, then negative 7 plus 4 must equal negative 3. And that's all there is to it. Okay, scrolling down now. Fractions, we've got addition, subtraction, multiplication, and division. Go ahead and pause the video. When you're ready for solutions, let me know. All right, number 14. I have 3/5 and I have 1 more fifth. Altogether, I have 4/5. Can't have 4/10, remember. If I had 4/10, it wouldn't make any sense because 4/10 would reduce. 4/10 would simplify to 2/5. Now, does that make any sense that I'm going to have 3/5, add another fifth to it, and I have a smaller number of fifths? No, it doesn't make any sense. So start making sense. Think about what you're doing. Don't just try to regurgitate. Okay, on this one, I need a common denominator. I'll count by the larger number, and I'll stop when I write down a number that the smaller denominator goes into. So I'll say 8, stop! So I need to turn the 4 into an 8. Multiply by 2, multiply by 2. Again, you can go back and watch the videos. My new problem becomes 5/8 plus 2/8. Well, now it's just as easy as problem 14. 5 and 2 is 7. I must have 7/8. Okay. All right. Let's see here. I'm going to count by the larger denominator. I'll stop when I get a number that the smaller denominator goes into. So 12, 24, 36. Stop! My common denominator is 36. So I'm going to turn 9 into a 36. Means I have to multiply by 4. Then I'll have to do it in the numerator and denominator. Turn my 12 into 36. I'm going to have to multiply by 3. But if I do it in the denominator, I have to do it in the numerator. Otherwise, I'm changing my fractions. Okay, my new problem becomes 9/36. How did I get 9? 3 times 3 minus 8/36, which ends up being 1/36. Now, it didn't happen on either of these 3 problems, but I always want to look to see if my final answer can simplify. Because if it can, I need to simplify it or I won't get full credit. Okay, problems 17 and 18. Remember, I want to try to simplify 4 different ways. Vertical on the left, vertical on the right, down to the right, and up to the right. I'm going to try all 4 ways. I don't have to try them in that order, but I'm going to try to simplify in all 4 directions. If I completely simplify, then my final answer will be simplified. I won't have to simplify it further. Okay, well, right off the bat, I see that 6 goes into these 2 here. So I'm going to divide that by 6 and turn it into 4. And I'm going to divide that by 6 and turn it into 6. Now, I just realized I could have used 12. I missed it, but that's okay. Watch what will happen. All right, 6 goes into 18, so I'll divide 6 by 6 and get 1. I'll divide 18 by 6 and get 3. All right, now I can do 3 into 30. 3 will go into 3 once. 3 will go into 30 10 times. So right now, my problem is 4/10 times 1/1. I've got one more step to simplify. If you can tell, I did this one, I did that one, and I did that one. Still got to do over here. So 2 goes into both of the numerator and denominator. 2 goes into 4 2 times. It goes into 10 5 times. Everything's been simplified. 2 times 1 is 2. 5 times 1 is 5. And there you go. Division is done the same way, except I'm going to have to remember to change it to a multiplication problem and use the reciprocal. I had a student last year that liked to call it the refliprical. It's not good grammar, but it helped her remember to flip her fraction. All right. Now, right off the bat, I see on the vertical left, I see both of these can be divided by 10. So that'll get me 2, and that'll get me 5. So I've done this direction. Then I see that 5 goes into 25. Could I do 5 into negative 30? No, because they're both in the denominator. I have to go upstairs, downstairs. All right, so I'm going to divide 5 by 5 and get 1. Divide 25 by 5 and get 5. Finally, I see that I did that direction. I see that 5 goes into 30. So I'm going to divide 5 by 5 and get 1. Divide 5 into negative 30 and get negative 6. I'm going to rewrite my fraction because it's a little messy. 2 over 1 times 1 over 6. And let's see, I checked this way. So now I still have to check down to the right. And look, I have a 2 and a 6 when I go down to the right. Divide 2 by 2 and get 1. Divide 6 by 2 and get 3. I've checked all 4 directions, simplified as much as I can. 1 times 1 is 1. 1 times 3 is 3. And there we go. The answer is 1/3. All right. 2 simple 2-step equations. Go ahead and see what you can do with them. All right, I'm going to go ahead and solve them. First thing I'm going to do is, remember, I'm going to listen to Saddam. That means to undo subtraction and addition before I undo division and multiplication. I'm going to subtract 20 from each side. These will cancel, leaving me with negative 3x, which will equal 9. I'm going to divide each side by negative 3. Divide by negative 3. X will equal negative 3. I can check my answer like so. 20 minus 3 times negative 3. And let me see what that equals. Well, I'm going to get 20. Negative 3 times negative 3 is positive 9, which equals 29. And look right here, the original problem equaled 29, so it checked. All right, this one here. Listen to Saddam. I'll undo the addition before I undo the multiplication. I'll subtract 3 from each side. 5x equals 17. Divide by 5. Divide by 5. 5 goes into 17 3 times. 2 left over. 2/5. And there we go. And again, you could check it. I would check it with 17/5. I wouldn't check it with 3 2/5. Oh, by the way, if you gave me this on a test, you would get full credit. It means the same thing. I know you may have had a teacher back in elementary school that said, never give an improper fraction. That's just not true. Okay, maybe it was true in elementary school, but in high school level mathematics, it's okay to do that. All right, dropping down to these two. Go ahead and pause. They're a little more involved. And we're ready to see my solutions. Go ahead and unpause. All right, I don't like that there are x's on both sides of the equation. So I'm going to get rid of the smaller x. Subtract 3x from both sides. And when I do that, I'm going to end up with negative 5 equal to 2x plus 7. All right. I'm going to isolate this x. Listen to Saddam. I'll subtract 7 from both sides. And that will give me negative 12 equal to 2x. Those canceled. And now it's a one-step equation. Divide by 2. X will equal negative 6. And could always check it. 3 times negative 6. I'm plugging negative 6 in right here. 3 times negative 6 is negative 18. Minus 5 ends up being negative 23. All right. If I plug negative 6 in here, I get 5 times negative 6, which is negative 30, plus 7. Well, 30 minus 7 is 23, so negative 30 plus 7 must be negative 23. And notice I get a true statement. Negative 23 equals negative 23. All right, let's check out this one here. First thing I notice is on my right-hand side, I've got some like terms. And I'm going to combine those on the left-hand side. 6x, on the right-hand side. Okay, and I'm going to get negative x minus 9. Now it looks just like the last problem. Add x to each side. I always want to get rid of the x that is smaller. Make my work easier most of the time. I'll get 7x plus 12, and that'll equal negative 9. I'll subtract 12 from each side. Why? Because the Dom told me to. And then I'll have 7x equal to negative 21. Divide by 7. Divide by 7. X will equal negative 3. Okay. Let me see here. There we go. Here's one where I can either distribute first or I can divide by 2. I think on this one I'm going to divide by 2 first. I'm not actually going to distribute. But if you want to go ahead and do it, pause the video, try these 3 problems. That's great. Here comes my solution. I'm going to divide by 2 on this side, and I'll divide by 2 on the right-hand side. Okay, these will cancel, leaving 7x minus 10. 40 divided by 2 is 20, and look at that. It's a 2-step equation. Add 10 to both sides. Get 7x equals 30. Divide by 7, divide by 7. X will equal 7 goes into 30 4 times. It's too short because it's only 28. And I divide by 7, 4 and 2 sevenths. Okay, this one is an interesting one. I'm going to get rid of this 3x. And when I do that, I end up with the equation 5 equals 10. That should bother you because there's no x in the equation. Ask yourself, when does 5 equal 10? It does not. So, since we got a false statement, this is no. Oops, that doesn't look like an L. This has no solution because 5 does not equal 10. There is no solution. All right, 25. Well, I've got some like terms right here and right here. And then I have some distribution going on. Boom and boom. On this one, I'm going to do it distributing. 7x and 5x is 12x minus 6. That's going to equal 2x minus 6. I'll subtract 2x from each side. And I made a mistake in the original problem. I'm solving it correctly, but I had wanted something else to happen, but that's okay. This is a good situation. And then I'll add 6 to each side. And I'll get 10x equals 0. Now, look, this is really a simple problem. You've got 10x equals 0. 10 times what number is 0? 0, of course. But I can show it by dividing by 10. So x will equal 0 tenths, or better yet, more simply said as 0. One more problem I wanted to show you. What if I had 2x minus 6 equals 2x minus 6? Well, I would subtract 2x from each side, right? and I end up with negative 6 equals negative 6. Ask yourself, when does negative 6 equal negative 6? It always does. A number is always equal to itself. So when you're solving, this is all real numbers. Okay, getting down to some graphing here. Let me get these out of my way. Okay, go ahead and try to graph. There's one equation. There's two more. I'm going to do those on the same graph. And there's a third one. Okay, you can pause and back up if you need to. Okay, here come my solutions. I've got to pick three values for x, and I think I'm going to pick negative 2, 0, and say 3. Gotta leave myself a little more room there. Okay, so I'm going to plug negative 2 in for x. I'll get 4 times negative 2. 3 is negative 11, I believe. So my ordered pair is negative 2, negative 11. Maybe this wasn't the best choice because my graph only goes down to negative 10, but only one off the grid, I can do a pretty good estimate. Okay, now I'm going to plug 0 in. This will turn to 0, and I'll end up with y equals negative 3, right? So 0 and negative 3 is a point on the graph. Okay, and then I need to plug 3 in. 4 times 3 minus 3. That's going to be 12 minus 3 is 9. So 3, 9 will be on my graph. Right there. And those 3 points should look like they're collinear. All on the same line. And even though I went off the graph, I'm still extending my line as much as possible. All right, make it go through the points. It does not stop at a point. Okay, so there we are. Good. Okay, coming down to the 27. That's a simple one because x is 4. So my three choices for x must be 4. Y can be any number. Any number. So I have the 0.4, negative 1, 0.4, 0, and 0.45. Okay, 4, 1, 2, 3, 4, negative 1, 0, and 1, 2, 3, 4, 5 is right there. And I'm ready to draw my line if I could only find it. There we go. Like that. Okay, so make that line blue. Ooh, that's a pretty blue. All right, very good. Okay, now 28 is a similar type problem, except y has to be negative 4. So I'm actually going to choose negative 4 for y, and then x can be anything. And maybe I'll go with 3, 0, and negative 2. So negative 2, 1, 2, 3, 4, 0, negative 4, and 3, negative 4 would be there. And I'll get a line, a horizontal line, that'll look something like this. And let me make it officially a line because right now it's only a ray. Ooh, I don't like that orange, but that's okay. You can still see the red points. There we go, something like that. So when it's y equals and there's no x in the equation, I get a horizontal line. When it's x equals, I get a vertical line. All right. On this one, this is a great one. I'm going to choose 0 for x, which makes my equation 2y equals 12, and therefore y equals 6. So I know 0, 6 is on the graph. 1, 2, 3, 4, 5, 6. All right, and then I'm going to choose 0 for y, which makes that equal to 0. So I'll get negative 6x equals 12. Dividing by negative 6x will equal negative 2. So negative 2, 0 is on the graph. Okay, now I need to pick on one more x value. I think I'm going to pick 1, and I'll get negative 6 times 1 plus 2y, which will equal 12. Well, this is negative 6. If I add 6 to each side, I'll get 2y equals 18. For y will equal 9. Y is 9. 1, 9 is on my graph right there. All right. There you go. All 3 points hit the line. And I'll make it extend through my points. And some other things you should be prepared to deal with. An equation where you have a fraction involved. I told you about those. Okay, you should be able to explain why when you divide by a fraction you get a larger number, like 7 divided by 1/2 equals 14. You should be able to tell me the quadrants, 1, 2, 3, and 4. You should be able to tell me that the signs are positive and positive, right? And negative x, positive y, negative x, negative y, positive x, negative y. You should be able to tell me the name of this line, the x-axis. You should also be able to tell me that y equals 0 on the x-axis. And on this line we have the y-axis. And that's the place where x always equals 0. And the name of this point here where they cross, which is the origin. And its coordinates are 0, 0. All right, like I said, this video is a little bit longer, but it was reviewing. You have 2 nights to go through it. Mr. Lawrence signing off. Have a good night, everybody. Good luck on your test.